With this, ladies and gentlemen, we'll move ahead to our first panel discussion for the day, which is on semiconductors value chain, India's participation in GVC. Ladies and gentlemen, now to our first panel discussion. I'd like to call forward our first panelist, Mr. Pankaj Gulati, the past president LCNA and Executive Vice President and CEO, Continental Device Private Limited. Mr. Pankaj Gulati has over 40 years of working experience in the semiconductor components manufacturing sector. He has worked in all segments in the semiconductor manufacturing, wafer fabrication to assembly and testing. He has conceptualized, planned and successfully set up an overseas office in Hong Kong. He also plays an active role in promotion and development of electronics industry in India. Everybody, with a big round of applause, let's welcome Mr. Pankaj Gulati on stage. Welcome, sir. Our next panelist for this session is Mr. Sumit Kumar Verma, the Senior Manager, Kane Semicon. Mr. Sumit is an ex-McKinsey and Ares Global with a large consulting experience close to 16 years. He has led organization-wide transformation program, working with C-suite executive to drive strategic engagements and top-line growth through GTM, M&A, and automation strategies. From the last few months, Mr. Sumit has been leading multiple keynote discussions at IITs for the semiconductor packaging programs, VLSID, and other key events. He was also instrumental in Kane's IIT Mumbai collaborations. Everybody, let's all put our hands together and let's welcome Mr. Sumit Verma. Welcome, sir. Our next panelist for the session is Mr. G.S. Madhusudan, the co-founder and CEO of Intercore Semiconductors Private Limited. Mr. Madhusudan is a technology entrepreneur and systems architect with 30+ years of global experience in diverse engineering and software hardware products, managing R&D lab and technology product strategy. Welcome, sir. Let's hear it up, ladies and gentlemen, with a round of applause, please. And our last panelist for this session is Mr. Rishikesh Shinde, the Senior Manager, Supply Chain Strategic Commodity Management, Lam Research India Private Limited. Mr. Rishikesh is a supply chain professional with over 18 years of experience in the semiconductor, automotive, and manufacturing sector, associated with organizations such as Mahindra Automotive, Volvo, Eicher Commercial Vehicles, and Ford Motor India in various domains such as purchasing, quality, plant engineering, manufacturing engineering. Welcome, sir. Over to you, sir.
Morning, everybody. Pleasure to be here talking about India being a part of the global value chain in semiconductors. Now I go back 5-7 years and I imagine and now I think how times have changed and transformed in these 8-10 years. I don't think it was ever a possibility India to be a part of the global value chain in semiconductors 10 years back. There was hardly any semiconductor manufacturing in India. But times have changed and we are all changing with it. The sessions on the first day and the morning sessions were very enlightening. I think each one of us now understands that this is the time, this is the right time. And for semiconductors, definitely it was a very encouraging presentation that I saw from Sri Ramaya on the semiconductor policy of Tamil Nadu. And I think many states are bringing out such policies. So it's time that we look into it. And semiconductors being a very wide spectrum, we'll try and zero in and focus on certain segments and areas where at least I believe that we can be a part of the global value chain. And I have a esteemed panel with me. In fact, we've had one round of discussion and we thought it's good, it's the right time for us to bring out areas where we believe that we can be part of how India can contribute and bring part of the global value chain. Now, I'll just start with a brief on the value chain and then I'll go through the panel one by one. If I understand correctly, global value chain comprises, or a value chain in is a three-step process. One is the design, the other is the manufacturing, and third is the sales. And I think India is already doing a lot of design on semiconductors and we have a lot of fabless companies, in fact quite large numbers based in India for many years. So in the design aspect, although we are doing design, but as rightly pointed out by many speakers in the last 1.5 days, that there is no real Indian design. The design is today being done for the international players. Now when you do a design for the international players, you then definitely do a design, but design is a property of somebody outside the country. And the manufacturing will automatically cater to that particular whether it's the country or the location or the requirement. But it's time that now India gets into its own design. You know, unless we design the product in India, and when you design the product in India, you design in the components, you design in everything. So that's one segment that I think I'll ask the panel to debate upon. And the second is the manufacturing part. Now, the manufacturing part is a very, very wide area when we talk of manufacturing. It's not just simple semiconductor fab or a semiconductor OSAT line. It involves also a lot of equipment, where I think the Lam Research and Applied team is working on the equipment. So it's the equipment, the production lines, and today morning's Richard showed a slide which was very good. It was a detailed slide on what all goes into manufacturing of a semiconductor. It was starting from the substrate, the compounds, huge list of materials that go in there, and today we are almost nowhere in that ecosystem. So that's the second segment of manufacturing. And the third is, of course, sales. And I don't think I need to touch upon that. India market is large enough. We are all projecting it to be a large demand segment. And India should manufacture not only for India, but also should for the world market. And this is what each one of us is looking at. Okay, I'll start with Madhu, sir, and take his opinion on what we've been discussing, sir. How can we contribute to the global value chain?
We first need to gather courage and we need to believe in ourselves. The problem is not technical. The problem is India does not have a culture of doing products. So the biggest challenge in creating a semiconductor product company in India is to hire a VP of marketing, not the technical talent. Technical talent you will find in the dozens. See, when somebody in the US gives you specifications and say develop, we develop it. Probably 30 to 40% of all designs in the world are happening out of India now. So it's not a problem at all. But if you develop a particular part, should it be a BGA package or a QFN package? It's actually a tough call, because you need to understand the value chain that that product goes into. You need to understand that the final product is going to be just a 4-layer PCB, maybe even a 2-layer. So if you do a BGA with a 2-layer, 4, you can kind of do 2 is pretty tough. Right? So that kind of extensive product knowledge is lacking. But we have an advantage. We are consumers of huge products. So my main thrust is we should focus on parts costing between 50 cents to $5. Don't go above $5, because most of the consumption would be in this range. Go for the older node products like compound semiconductors, power, IGBTs, RF and all that, right? With older technology and stuff. If we do that, I think India can actually supply between 10 to 15% of the world's demand. We are talking 15% of the world's supply of semiconductors in this segment coming out of India. Easily doable in the next 5 to 8 years.
Thank you very much. I think what Madhuji has just touched upon is very right. What we have been discussing in the semiconductors is that we've all been talking of fabs of nanos and sub-nanos and 20 nano, but I think what India needs is something, even a 180 nano or even a right up to 1 micron fab is good enough to meet India's own requirements of a very large segment, what he rightly said, between 50 cents to $5. Now, all these 50 cents to $5 would probably be hitting somewhere in the power electronics area. Now, the power electronics, when I talk of power electronics, it means it's a wide variety of products, which means IGBTs, MOSFETs, DC-DC converters, voltage regulators, and now a new emerging field of silicon carbide and GaN. So all these are power electronics products, the modules, the IGBT modules, and I think all these is something that can be done with a 180 nano to a micron fab. Easy to install such fabs, relatively low cost, and accordingly put in the OSAT lines. Now, if you start looking at the market that he is referring to, I think the power electronics market is about $42, $43 billion today. expected to go to $49 billion in 3 to 4 years. Or 10% of this is a huge chunk of market. And it's not impossible, because this is a segment of semiconductors which is on the lower end, the trailing end of semiconductor range. Most of the companies are today focusing on the high end, higher side, higher nodes, lower node levels, lower points, while this segment is today offering a large market and also a large opportunity for the Indian manufacturers. So, sure, sir, sure.
Forget this panel. Look up, look to your sides. Look at the number of devices in this room, number of LED lamps. Take the microphone. This is a 40 nanometer small part. It's not the MEMS is pretty trivial to do. The A to D converter, all that is pretty trivial, right? Like I'm saying, why are you looking to somebody else for inspiration? Do a BOM analysis of the room you're sitting in. That's all you need to do. You don't need to come to an Elcina conference to figure out where the demand is.
Thank you. That's right. That's right. Most of the demand is into the discretes, into the MOSFETs, into the IGBTs. Okay, I'll go on to Sumit now, and would like to understand Kane's what future plans and how would you contribute into this semiconductor arena.
Thank you, sir. Thank you for giving me the opportunity to speak on behalf of Kaynes Technology, and more specific, Kaynes Semicon, the currently formed subsidiary of Kaynes Technology. I'll try to look from the bigger picture of it before I deep dive into it. I'll say that we talk about, I'll put it like that. India has always been known as a services company. You talk about TCS, Wipro, HCL. US, Europe, everybody knows India because of these companies. India would hardly know about anybody of Reliance or Tata. If we talk about the only car we have is Tata Motors, which is a big car. But how many years have taken to really come down to this level today? So we need to understand that what we're trying to do with respect to OSAT semiconductor is a very high-end manufacturing. It's not something that you just develop something which is very simple. Not with respect to the technology, the capex required as well. So when we talk about that, we say, and as I was mentioning, that India has been a design powerhouse, and we have approximately 20% of the workforce of the world which is working for the companies outside India. So again, what we are doing for semiconductor in the design space also is not for India. We are being outsourcing it. So that's again a part of you need to understand that even before we move to the main front-end manufacturing, which is OSAT or fab or wafer, what we call it, we need to understand that the ecosystem around it, how good we are with that part of it. And given we are an EMS company, it's been in Kaynes Technologies is in the sector for the last 35 years. And we have seen that how we have been able to gear up, understand the challenges, and especially around the COVID times, what all challenges we had in procuring the raw material. And when I say raw material, there are two important parts of raw material. One is the bareboard PCB and other is the ICs. And we all know where the ICs come in from the market. And we venturing into this sector, which is a backward integration of getting the bareboard PCB and OSAT, which is the ICs, the other component, important part, which includes in the PCBA, is something to give ourselves an edge with respect to the entire end product that we source for our clients.
Thank you very much, Sumit, for giving us an idea of what you're planning to do. In fact, that's right. Although it doesn't directly concern semiconductors, but I think PCB is the basic building block for any electronics that we have to do. And there were a lot of announcements yesterday, a lot of excitement yesterday on the PCB side. So it's good to have a company which is venturing in, more companies coming into this, and will probably help the India infrastructure on the ESDM. Now I'll go on to Rishikesh. I think you are probably from the Lam research, am I right, sir? And that's contributing quite a bit on the equipment side. Correct. And you have identifying a lot of vendors in India, and you're working with developing more vendors on your equipment, correct, which is the building block of any semiconductors. Now, if you look at semiconductors, it's not just manufacturing. You have to have the equipment. CDL as a company, we've been building semiconductors, although on the discrete side, for almost 60 years. We know how difficult it is for us to maintain our equipment. There is hardly any service support. Even till date, even on an OSAT line, if we buy, I start buying with a dicing saw. We have about 7 or 8 dicing saws in our plant, which is coming from Japan. We have die bonders from Europe, from US, from Japan, from Korea, from China. We have variety of equipment. Each set is very difficult to maintain, and it's being done by our own engineers. So you can well understand on a process line, which is a continuous running line, all equipment maintenance is important. So it's important that India builds that strength of having equipment manufacturing in India, equipment support in India. And I think large companies which are now coming from the multinationals, the Microns and the other companies, they are bringing in certain set of service people from the equipment side. But it's important that we start building that equipment. I think Lam and Applied are the two companies which are working towards this, and I would like to have your views on this, sir.
Yeah. Thank you, Elsina, and thank you everyone for giving this opportunity here. One thing, first of all, before starting, I would like to agree with you, sir, when you said that around 4 to 5 years ago, it was very difficult to even consider something like semiconductor being sourced from India, semiconductor parts. And I remember in 2019, when we used to pitch this idea to our US counterparts that, okay, India is having a very good aerospace and automotive supply chain. Why don't we use that? So that was not a thought which would have been considered at that point of time. But today times have changed. In fact, it is our policy, and we have committed a significant amount of our purchasing value to be coming from India by 2025. We have established a specific sourcing group which is dedicated and working to identify suppliers as well as identify commodities which can be sourced through India. There are some individuals specifically stationed in India who are working, and I'm fortunate to be a part of that group to identify suppliers in various categories and various commodities. Now for the sake of discussion, I would just like to divide the commodities into 3 groups so that we all can understand what I'm talking about. One group is those part of components like which are fully OEM designed, OEM controlled, like RF generators, all the motors, etc. So that is something which will take some time in India to develop the supply chain and the capabilities. But what I would like to focus, or what we are focusing now, are basically 2 components. The build to print spec, that is where we just have the design is not vendor owned, but say for example Lam owned, and then supplier can build the process for that. So this consists of all the machining, forgings, and sheet metal parts, weldments, etc. So that is something which we think that India can very quickly scale up and grab that global market share as of today. And the second thing which we are focusing is the integration part. So when I say integration, that means assemblies like power boxes, gas boxes, cable assemblies, where there is some portion of build to print spec and some portion of OEM components, and maybe the labor charges we need to assemble that. Now, when we focus on the first part, which I said, which is completely build to print, which consists of casting, forgings, sheet metal parts. I think so that is the area where we can very quickly scale, or we can utilize the inherent competitiveness of Indian supply chain industry, because we have been quite at the forefront of automotive and aerospace. So that is something which we can quickly scale up to. There are still some challenges here. The typical kind of structure in semiconductor industry is low volume and high variety, which is complete opposite to automotive, but typically similar to aerospace industry. So that is something which we can quickly change, we can quickly cater to. Another thing is lot of semiconductor equipments require clean room machining and 10,000 class clean room cleaning. So that is something which we need to see how our suppliers or how Indian supply chain can quickly adapt to establishing quick clean rooms. I was very happy to hear some of the government delegates before, Manjunath and Ramya, saying that they would like to support the Indian industry to set up some clean rooms and etc. So that is something which we need to have. Another thing is we need to have accessibility to some specific grades of raw materials. We often find it difficult that whenever we do some RFQ studies in India, the raw material cost is very high because they need to buy that raw material from Europe or somewhere. So that is something which we can quickly think of how we can establish that. Anodizing treatment plants, etc. In weldments, when we see semiconductor requires a welding in a completely clean room. So it's and it's a specific kind of welding, orbital welding, which we don't often find doing our suppliers having here. So we are India is we are there in welding, but the kind of orbital fine welding which we need, that is something the need of the hour, where we can see we can establish specific clean rooms and weldings in the clean rooms in the for the larger OD and smaller OD type of parts. So I think so, and of course the batch sizes and how we can frequently mix the things. So I think so, if these typical things if we take into account, definitely we have a huge scope to cater the supply chain. And the second thing which I would like to mention about is the integration part. Now integration part typically consists of components such as power boxes, gas boxes, cables, cable assemblies, etc. Now these components, they have a mix of OEM parts, mix of BTP parts, and then remaining is something, you know, the labor component into that. Now what happens here is almost 30 to 40% of a cost of that equipment consists of bought out components which are kind of source locked. And even today, if we check that with an Indian supplier or an Indian vendor, they had to go and get those components from European or US MNC or the OEM component. So it might be, in case of power boxes, it can be connectors, it can be cables, it can be circuit breakers, etc. In case of gas boxes, it can be complex valves, regulators, filters, mass flow controllers, etc. So that is something which we have to get it from outside. Now the global integrators with whom our Indian new vendors are competing, the global vendors may have a very huge buying scale, and that is the reason they can get advantage of scales. Whereas when we are trying to go first enter into that market, we are not able to get that advantages of scale. So that's the first entry barrier which we get. We are working with our designers and engineers to qualify Indian alternatives for those. Also, secondly, we are working with some of the OEMs, like we are working with Belden if they can put a plant in India so that our Indian vendors can source from them. We are working with Horiba if they can set up the mass flow controller plant in India. Alpha Wire we are working if they can work on India. So if that OEM component comes into India where we can buy that at a much better economies of scale, that would be a better thing for us to be competitive in the global space. So I think so these are some of the things which we are doing, but overall I think so we are we have a dedicated supply chain now specifically focusing on India.
Thank you so much, Rishikesh. Now you see what is happening is that companies like Lam and similar companies Applied, they are building the basic blocks of equipment manufacturing. They've started with sourcing of components, they're building the vendors, they're training the vendors. You know, all this is helping. It's not just for Lam, it'll help every industry in India. These are some of the technologies that we probably have missed out in the past so many years, which has now come in. I'm sure when he talks of getting those mechanical parts, it's not simple just getting a part. Even the welding is being done in a clean room, which I don't think many of us understand the importance. So companies like Lam are helping build the basic infrastructure ecosystem in India to somewhere down the line start manufacturing. Now, I'm sure some of you would have seen the wafer fab. If you see the fab, each equipment is so precise. It is such a delicate piece. When you're talking of course, when you talk of nanometers line widths, it's basically a distance between two lines on a wafer. Now, to get that type of a precision, the equipment has to have the capability, and building that equipment or getting the parts made of that equipment in India is helping build the basic infrastructure, basic ecosystem for manufacturing. The panel here I am very fortunate to have, which is starting from the design and the product, going down to the PCB and the board assemblies and down to the equipment. So each of the discussion that we've had is basically showing that India today is working on the complete aspect of semiconductor manufacturing. Not just the design, and what Madhuji just said was so right, that let's focus, and with an apt example, if you look around you, there could be 2 or 3 microprocessors, ICs in a circuit, but there are multiple power electronics, small signal devices, discretes, IGBTs, modules sitting around that. I think when you talk of building an IC or building that type of a cutting edge product, you are talking of IPs, you're talking of wafer fabs which are running into billions of dollars, and you're talking of IPs and the libraries that you have to actually pay for before you start building that. And then you talk of OSAT lines which again run into a millions of dollars to set up that type of a precision. India, we have to start somewhere. Let's look at the fabs which are doing the MOSFETs, the fabs which are doing the IGBTs, the fabs which are doing the shortkeys. Lot of market in that. And the OSAT lines for that will not go into a millions of dollars, but probably a couple of $1 million. And that is relatively easy to start. The ISM, the government policies earlier were all catered towards high-end fabs and high-end assembly lines, but now they have already modified that in the ISM specs, which says that they are even giving a 50% pari passu on the discrete semiconductor, because I think everybody now realizes that's an important section that we cannot ignore. A $49–50 billion market we cannot ignore. Madhuji, would you throw some light more on towards the power devices, please? Thank you.
Well, my first electronic design was a SMPS power supply. I think I was 14, 15. It had a switching transistor, and that was made by GE. Bell used to make power transistors back then, PN3055s and stuff, big little things with a metal head. Bell had an excellent component manufacturing, which got wiped out. But the switching transistors even back then used to come only from abroad. I think GE made one. My father was running National Textile Corporation, so he had a board meeting up in Bombay. So after the board meeting, he had to go to Lamington Road and source the transistor for me, right? So he spent half a day. I think he cancelled some other meetings, and he couldn't send his secretary also because the secretary didn't know what it was. Power products have always been a problem. Power is a single point of failure. Anytime an ISRO mission fails and stuff, if you look at it, invariably it will be a power device, right? And we are fortunate to have Salcomp in Chennai. We have, right? But we don't have the parts. Fortunately, there's one startup that is coming. It's still stealth, but soon we will have IGBTs, MOSFETs, silicon carbide devices, gallium nitride devices. See, again, you need to understand products. If you take power in RF, so one thing that we need to do, and sorry for digressing, ELSINA needs to, we need to go beyond this conference, correct? We need to identify a set of devices, work with the suppliers, and agree that we will get those parts out in volume, say by 2026. Unless ELSINA can drive this to fruition, there's no point advocating. We can all go sit in MeitY, give a presentation to Rajiv Chandrasekhar or Vaishnav and say, sir, you should do this and all that. Everybody nods, you all have a cup of coffee, come back, we're back to square one. Next conference, we keep saying the same thing, right? That's what's been happening. Why not set a goal saying that by 2026, this is what we'll be producing locally. But we need to understand the market. The Wi-Fi Bluetooth dongle market is the biggest in the world. There are two aspects to it. Texas Instruments has gotten out of that market completely. The whole market is flooded with Chinese components. Panasonic buys 100% from China now, from Espressif and so on, right? What do you need for that? You need a small gallium nitride power amplifier for 2.4 gigahertz and 5 gigahertz, right? So that is a part that we need desperately, because this $250 million smart meter thing needs wireless connectivity. All of them need a gallium nitride power amplifier. Similarly, all our EV needs silicon carbide devices. So I frankly feel Elsina should make a list of devices critical to India. Forget about export, our local consumption, and essentially go at it by war footing and ensure that by 2026, a typical EV's power devices, Wi-Fi, Bluetooth, Zigbee, home automation, couple of other small devices, these parts should have at least 3 Indian suppliers. Now, if you take a part, the problem is I'm a design company, but to get to manufacturing, I don't have money. Now, if I go to a venture capitalist, it's a different problem. See, manufacturing device is also cash problem. So why can't Elsina bring distributors like Abnet and Arrow, bring the end consumer to the table together and figure out how to fund that device? There is enough money sloshing around in India. I mean, I jokingly told the government, whenever you do an ED raid, tell them they'll get an amnesty if they invest in semiconductors. That's the only amnesty you should give. Right?
Yeah, right, Madhuji. That's a very interesting point he raised. But I think these days, let me just update you, apprise you on the various discussions that we've been having on the semiconductors section. With the new policy that's come in on the specs under the ISM, I think there are plenty of companies that have now shown interest, and applications have already been filed in. I'm aware of at least 2 companies in this segment of power electronics who have already started the investment. Being under it's a privy information, so I can't share the names, but they've already started that investment. So the horizon, the market manufacturing of these products in the next 3 to 5 years will be a massive change. They are all into power. They're talking of high power devices and similar range of MOSFETs and IGBTs. And CDL, as our company, we've already started silicon carbide manufacturing. We are exporting today. 100% product of silicon carbide is being exported, because in India we don't have the market developed to that extent that we start selling in India, but there are discussions on with the EV charger companies. So we are doing silicon carbide. We are already started the prototype assembly of gallium nitride power amplifiers. And this is the segment that I think as a company, CDR is also going to focus in the power electronics segment, with the silicon carbide, gallium nitride being the forefront, the new products, and then running right behind it are the MOSFETs and IGBTs. So situation is changing. It's true that we are very slow. And the reason behind that has been very clear, what was discussed yesterday also. Capacities are about 70–80% loaded. The product comes in at a zero duty under the ITA. It's very difficult for a private investor, for any investor, to venture into a segment in which you can get the component on a zero duty from the neighbors, and you already have some capacity sitting which is only just about 80% loaded. It requires a lot of deliberation, and what you rightly said, we have to start from the market. You must look at the market. Availability of the market is the first thing any investor or any manufacturing company would look at. And power electronics, what he rightly said, is what fails the maximum in a circuit, is what requires the maximum attention. And this is not something very simple. If you look at a power electronics package, it's a 220 or a 247 on those large power packages, what Richard was showing in his graph. It requires a lot of interface. You know, power devices can go as high as 150 degrees, 200 degrees temperature, and then drop down to almost to a room temperature, although the testing is done from -55 to 150. We do that testing for every power device that we manufacture. So the manufacturing of a power electronics may look simple. It's a standard 220 MOSFET, but what goes behind it is a lot of technology and a lot of material, which of course we are working with McDermott on a lot of high power devices for special materials. So it's not just simple assembly, and technology wise India has lagged in that segment. So we have to develop that, what rightly said in the morning, we are working with IIT Madras, we are working with IIT Bombay to develop certain high power technologies, and hopefully, sir, we'll give you a surprise in the next 2 to 3 years when you'll see a lot of power devices being rolled into India by the Indian manufacturers. Now, coming to Keynes, besides the PCB and the EMS that you have, are you also planning to get something into the semiconductor side, not now or maybe later?
I think everybody, most of the people here would know that we have already announced that we are venturing into OSAT. Yeah. And before I deep dive into that, I try to give you a bigger picture of we are moving from services to manufacturing as a country. And deep diving into that, I would try to say again, specific to the OSAT, a semiconductor, that we need to again understand a little more deep dive way that we have to understand factors which are tangible and intangible. When I say tangible, they are, as sir mentioned, and the senior panelist member mentioned, we have copper wire, lead wire, copper frames, and wire bonds, which we have to import, which are the tangible part of it. That's one part of it. The intangible part of it, which is equally critical, and which I would say is a chicken and egg kind of story, which is the skill set requirement for it. And again, it's again an entire ecosystem. When I say the skill set, it's not just the people who from the IITs or the engineering college. I'm talking about the skill set for somebody to know how to operate the machines, how to work around it, how to understand the process, how to make sure that given that EMS is still something we can have a yield of, let's say, 95%, 96%. But you talk about semiconductor or OSAT, we need a yield of 99% above. Otherwise, it's something which is not profitable, not good enough for any company to be in. That is how we look at, and you know, being a public company, we have to also look at the board of directors, and everybody knows that. So, okay, the second part of it, I'll talk about that when we as a country, that the government announced some time back the $10 billion PLI for the semiconductor space. After that, we have Micron coming into Gujarat. We have multiple announcements from different companies like Tata, Sahasra, and Keynes himself, and we have CG Power also announced that. But what we need to understand that we need to have a proper ecosystem, which is not just the OSAT or the design or the fab. We need to understand the companies around it which support in different ways. We need to understand the machineries, the gases, all the tangible and the intangible part of it which are required for that. We need to understand that in India we have multiple medical clusters around different parts of the country, north, south, and everywhere. We have a very robust railway policy now, which we have seen in terms of how the multiple Vande Bharat Express has been announced by government, not just multiple, hundreds of them. So we need to understand that as we move into OSAT space, for it really to be successful, we just don't need to have the PLIs into the mainstream companies, into the value chain of the semiconductor, which is design, EMS, OSAT, and fab. We need to understand we need to have the supporting policy for the companies around it. As sir mentioned that the smaller, the startups, the R&D houses, again, I'll more specify again that we need R&D houses which are specific inward, not just outward. We're supporting Indian companies and developing the entire ecosystem as a part of it.
Right. I think Sumit touched on a very right section, which is the ecosystem for manufacturing of semiconductors. Now, what he rightly said and what we have been experiencing for over 50 plus years is that everything is imported. All the raw material is imported, means lead frames, bonding wires, molding compound, the epoxy, the die attach epoxy, the paste, everything, including high temperature sockets. Can you imagine if I have to test a product of semiconductors which we manufacture in millions? Today we are doing almost close to 20 million pieces a month of semiconductors in our plant in Mohali. So almost every product, and we are supplying to automotive, which means AEC-Q approvals, and these products go through an extensive reliability testing. Now, every socket that we put in, which goes up to 150 degrees, from -55 to +150, the socket is imported. We do not have a socket manufacturer in India which can withstand this temperature. So what he rightly touched upon is the right ecosystem. But I think Micron definitely is a large company which has come in, and they've already brought their substrate manufacturers along with them in the same area. But when I believe that if we look at what Madhuji said, look into the power segment, and which is relatively easy OSAT for many of the companies in a relatively lower investment figures, you have not just one Micron, we probably have about 7 or 8 or 10 OSAT smaller lines which could even be a part of the MSMEs. When you have 8 to 10 OSAT lines in India, the manufacturers of the material will themselves start thinking India market is now viable for them to start manufacturing here. I've had a discussion with the molding compound and the lead frame manufacturers, and they're waiting to have at least 2 or 3 lines start up here, because their volume output is so high with no consumption in India. They are not today willing to commit, but they're all willing to come in. So hopefully very soon, moment we have these 2-3 lines in operation in the next year and a half, we will have these ecosystem lines also come in. I can assure you that.
Just to add to the point where I left was, just to give you the size of the opportunity that India has is, in 2018 we imported almost $8 billion of ICs from around APAC and global. And in 2021 it was almost $12 billion. And of that $12 billion, close to 52% came from China and Hong Kong, that area. And given that the US, the China plus one policy, I think this is the right time that India should try to leapfrog with respect to the policies creation, not just for the mainstream companies in the value chain of semiconductor, but also the ecosystem around it, and to make use of this opportunity.
Thanks, Smith. Okay, Rishikesh, one question that in the end from you, it's good to hear that you're sourcing so many parts, so many small parts, and which is helping develop the manufacturers in India. But somewhere down the line, do you think Lam has a plan to manufacture something larger than just the small modules? I know it's too early for me to ask you that, but there could be some plan, because your companies make a long-term vision planning. That, do you have any such thoughts coming in?
Yeah, so to be very frank with you, this is the most common question which we ask to our policymakers also within Lam. And again, I would like to say, you know, I agree with you and what Sumit said. Today, there needs to be an ecosystem here. So, for example, if you see semiconductor equipment, it is having some products which needs to be very close to the factory. So, for example, the chamber where actually the chip etching and deposition takes place, that chamber is to be machined and anodized in a fully clean environment. So we have those global giants established near our current manufacturing plants in US and Malaysia, which are at very close distance from us. Then we have some of the frames which are very complex frames, which are being welded and which are machined in a fully clean environment and also anodized and clean. So if this kind of ecosystem and supply chain is there in India, then it will be a cakewalk for not only Lam but in even any other OEM to establish the plant in India, because these are the, I would say, the driving decision makers for any plant setup. Cost of some of the very high value and high mass components. So, and there are different things, like, as I said, that if you see the 3 building blocks, then we have the machining and we have the integration also. So when this like gas box, that is also one of the very important component of semiconductor tool, which is actually used to regulate and control the flow of all the reactor gases into the chamber. And it has a lot of OEM components from all the global OEMs. So, and it would be very difficult to import these kind of components from somewhere US or Korea to India. So, once this associated supply chain is established in India, then semiconductor tool is just an assembly.
Yeah, right. Rishikesh, you must be wondering, why am I smiling when you were talking of those glass flow controls? Because I'm actually a wafer fab engineer and I've worked in the fab. CDL had a fab for a long time. So I still remember controlling the gas mass flow, and everything was imported. Mass flow controllers were all imported, everything.
Yeah.
Even the small gas flow, which we used to use argon, or we used to use the silanes, everything was imported.
Exactly.
There was nothing. If I had surplus inventories lying with me, if anything goes down, we used to replace the mass flow controllers point to point and send the thing out to Germany for repairs. So those were the days we've seen. Yep. But hopefully by the 15th Source India, we'll probably see you manufacturing some of that equipment here, and we'll see a lot of OSATs and maybe make Madhu's dream come true that his father doesn't have to search for 3055. And by the way, we still make that product, 2 and 3055. So let's hope things change. And we are all working towards it. Let me assure you, all of you here, and I'm sure if there are any questions, the panel is here to answer you those questions. And if not, then I think Rajuji. Oh, sorry, Sudarshan, please go ahead. Sorry, interesting question.
No, nothing interesting. As a layman, the general question that anybody has in mind, because we're all frightened by the semiconductor investments that is, going on in the country. It's always in terms of billions and many, many millions. So if I take the basic building and the clean room standards away, what is the minimum capex that would be required to start a simplest of the form of a fab? You can just explain in layman terms, that would be good. It would help a lot of us to demystify that, the big number that we have.
Excellent question. In fact, Madhu, Sudarshan, this question we have been debating internally in our company, because we had run a fab for 30 years. So it's time that we get the fab here. Now, if you're talking of a simplest of fabs, now I'll talk of a fab which can do sensors, MOSFETs, discretes, IGBTs, and let's talk of gallium nitride or silicon carbide. This fab, you don't need an 8-inch for this. 6 inches is good enough for this. If I go for a new fab, it could probably be $4 billion to $5 billion. But advantage is that these days, every equipment is available refurbished. Every single equipment fab, from the furnaces to the aligners, to the projection aligners, to the evaporators, to the E-beams, everything. Now, my friend sitting here may not like it, Rishikesh, because he's saying that I'm promoting a refurbished equipment, but I think Lam also does it themselves. See, I know that. All these companies, they do a refurbishing. When you're talking of a simplest of fab to cover this segment of semiconductor manufacturing, it could probably be brought down to about $2 to $3 billion. No clean room, no nothing. In fact, clean room building is also an art in itself. Other day we were having a discussion, not people understand, they say we put filters and it comes to class 100 or class 1000. That's right, it does. But the flooring also has to be vibration free, because when you're aligning the wafers, and it has to be a vibration free. So a lot of it goes in the building also, but that's separate expense. The fab will be $2 billion. The assembly line, typically about $15 million to $20 million will give a good assembly line, which will possibly match a device output of around 10 million power transistor pieces a month, if that answers your question. Thank you.
Thank you for this clarity.
Thank you. It's still a lot of money, yeah. Anybody else, please? Or we call it Rajuji, then stage is yours. Yeah, please, Nicole. Thank you. Thank you, everybody. Thank you.
Thank you, gentlemen. I request you all to please be seated. May I now request Mr. Raja Goel to please come forward, speak a few words on Semicon India 2024.
Hello. Yeah, I would just like to add this Semicon India show, which is the Semicon, it's a curtain raiser. Semi is a US organization for all semiconductor manufacturers worldwide. They hold a very, very large membership. And this is the first time they're promoting a Semi India show, which is coming with the MMI Electronica show in Noida in September. And let me just tell you, I've been fortunate to attend this Semi show in US and in Europe for the past over 20 years. And I was, in fact, in the last curtain raiser, I was telling somebody that just in, I think I remember that year 2002 when this show was being held, and it started in Shanghai. And I went there with my senior, my boss, and I was looking at the show in Shanghai and all the semiconductor companies around. It was very fascinating to see the bonders and everything right there. And I was looking and I said, sir, will I ever get to see this show in India? And this is just about 20 years back. It's a dream. So I would suggest that all of you involved with the semiconductors, being in the industry or interested to get into semiconductors, do try and attend this Semicon India show. You'll probably not only have the Indian manufacturers, but many, with SEMI being a worldwide organization, they have members all over the world, equipment suppliers, material suppliers, everybody will be there. So ecosystem, everything. I am sure Lam would also be there somewhere, because everybody will be there. So Rajuji, can you play the small short video? Lam is there, right?
I don't think.
So there it goes. Lam is there, Pride will be, everybody will be there.
Yeah. So Pankajji, I think you said almost all of what needs, needs to be said about Semicon. The only thing is that I would like to highlight that this is being organized or co-organized, because this is the first Semicon India being organized by SEMI, and it will be happening in September in Greater Noida, in the India Expo Mart. This will be actually, this is the third one in India, but the first two were organized as Semicon India, and it was spearheaded by METI. Semicon is actually a brand of SEMI, and this is the first one which they are now doing, and from now onwards, they plan to do one every year. So Elsina is a partner and a supporter of SEMI in India, and particularly for co-organizing Semicon, and for other activities that we would also like to participate with them, like in developing, the supply chain and the skilling, which are the two main areas where we'll be working with them. So, SEMI is like, this is something which is very sacred to them almost, and I think this is going to be the 8th, they do 7 all over the world, and this will possibly be the 8th one. So it will be a great opportunity, and SEMI is so strong, and they bring the world ecosystem with them. So I think anybody looking to play any role in this entire, in this entire supply chain or value chain, which is really huge, so should be there and should participate. It is in September. I think the dates are 11th to 13th of September this year in Greater Noida. And I must recognize the presence of Miss Maya Suresh, who's from SEMI India. She represents SEMI in India. She is here. She is based out of Bangalore. So, welcome, Maya ji, and thank you for joining us here. I would now request Yogesh to please play the small film on SEMI. Thank you very much. Thank you.
Thank you, Raju sir. And now I'd like to thank in a special way our panelists for the session. Let's hear it up, ladies and gentlemen, with a round of applause. And can I ask Mr. N. Ramachandran, the CMD Mel Systems and Services and Chair Organizing Committee Source India, to please come forward and present the mementos to our panelists. I'd like to thank in a special way our moderator for the session, Mr. Pankaj Gulati, the CEO of Continental Device India, with a round of applause. Ladies and gentlemen, let's hear it up, please. Mr. Sumit Kumar Varma, the Senior Manager, Kane Semicon. Let's keep the applause coming, everybody. Mr. G.S. Madhusudan, Co-Founder and CEO, Incore Semiconductors Private Limited. And Mr. Rishikesh Shinde, the Senior Manager, Supply Chain Strategic Commodity Management, Lam Research India Private Limited. Thank you very much, gentlemen. Can I request all of you to please come together for a group photograph? Thank you once again, gentlemen.